by itself on one side of the equal sign. Don't you see in the top guy that x is all by itself? So the way I teach it way back in Algebra 1 is I say put a box around this and put parentheses around which variable is by itself in the other equation. And we are going to substitute. What's in the box goes in the parentheses. Aren't we putting 5y plus 12? Can't we substitute that in for x in the bottom equation? So rewrite this, brother, but what's in the box should go in the parentheses. Since x is 5y plus 12, I can substitute that in for x in the other equation. And now in this red guy, there's nothing but y's in there. I could solve for y real simply. This would be 15y plus 36, by just distributing, plus 4y equals negative 2. 15y and 4y are like terms on the same side of the equal sign already. That is 19 total y's plus 36 equals negative 2. 19y equals negative 38. And that means that y equals negative 2 when you divide both sides by 19. You cool with how I figured out what y was? That's only half the answer, though, because I want to know where these intersect on the graph. I know the y value. I need to find the x value. So I need to substitute negative 2 back in for y to figure out x. You could choose either one of these equations, but if you put it back in the box, there's an x already all by itself in that situation. So you could say x equals, do a little mental, negative 10 plus 12, and negative 10 plus 12 is a positive 2. So as an ordered pair, that is x comma y, 2, negative 2 is where those intersect. Awesome. Next one, also solve by substitution. If there is a variable all by itself on one side of the equal sign, that is good. I know what y equals. Boop, 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 boop. Y equals this, so I will substitute that in for y into the other equation. 2x minus 3 times the quantity of, you always substitute into parentheses, 5x minus 18. That should equal 2. 2x minus 15 plus 30, 54, is that right?
Yeah.
Equals 2. This is negative 13x equals negative 52. X equals 4. I'm doing the algebra very quickly. Stop me if you don't understand what happened. That's only half the answer. I need to figure out y. When you're doing substitution, I always say figure out the other variable by substituting back into the box because that's where that variable is all by itself. So y equals, you can pretty much see it, 20 minus 18, shouldn't that be 2? Right? I'm doing a little mental. 20, take away 18, 2, so 4, 2. Questions? Substitution. You can do it anytime. It's a piece of cake when there's a variable all by itself already on one side of the equal sign. They want this to be solved by elimination. That's the one you're most comfortable with. We do that the most often. What has to happen, though, x's have to be on top of x's, y's have to be on top of y's, equal signs must be on top of equal sign, and constants are on top of constants. Isn't it all ready to rock for elimination? Cool. What do you want to cancel, x's or y's? What would be much easier? The y, since this is a 6y, I can turn this into a negative 6y very simply by taking that top equation times positive 2, because he's already negative up there. So far, so good. I rewrite him. You with me, Keith? I didn't know if you were alive. Cross him out. Gone with the wind. 13x equals 13 minus 26 is a negative 13. I want to stop right there and realize I will get solutions to this. How do I know I don't have infinite solutions or no solutions? Because when I eliminated, are there still variables left over? There's still an x in there. I can solve and x equals negative 1. Correct? Then to find y, pick any equation you want to. You have 3 of them to choose from, to be quite honest with you. And then put negative 1 back in for x and solve for y. So I'll pick Mr. Top equation, the original guy, negative 4 minus 3y equals negative 13. I put negative 1 in for x, right there. 4 times negative 1 is negative 4. Add 4 to both sides. a negative 9, and then y equals a positive Shawi. Again, just basic algebra refresher on how to solve a system by hand. Questions? Next one. Problem with it. They want you to solve by elimination, but the main problem is stuff's not all lined up. You don't have x's on top of x's, y's on top of y's, etc. So let's rewrite this one. First of all, don't you need this 4x to come over here? How do you get him over there? So I'm going to have a minus 4x. I'd have to subtract him over, correct? The 6y, is he on the right side, the correct side? Yes, and he's a positive 6y. This minus 12 is on the incorrect side. Don't I need him to go over to the other side? So I will have to add 12 over there. All I did was rearrange those terms in the order I wanted them to be in. Groovy? Canceling a variable, it's whatever you want to. I would choose the x's since they have smaller numbers involved, and I think 20 would be a great thing. Turn this guy into a 20, turn him into a negative 20. Cool. What would I have to do to turn him into a 20? Take him times 2, of course. What would I need to do to turn him into a negative 20? Take him times 5. I roll off to the right a little bit when I'm multiplying on these. That'd be 20x minus 30y equals negative 50. And this is negative 20x plus 30y equals 60. Right? Oh no! Gone, gone, 0 equals 0. Oh no. Is that no solutions or infinite solutions? And that's not enough. Infinite solutions in the form. Because, see, not every answer in the world works. You say infinite solutions, you think that anything you want to as an ordered pair works. No way. You graph the same line both times. These points must be on that line. So what I do is I set up this generic ordered pair. Infinite solutions in the form of x, comma, blank. And I'm going to fill in that blank. Would you believe that what goes in that blank is y? Aren't ordered pairs always in the form x, comma, y? We need to figure out what y equals. So what we should do is pick one of these equations and solve for y. Figure out what y equals. Let's not use that one. Those numbers are too big. Let's use this one instead. Let's solve for y. So here it is. I'll slow down because I know I'm moving pretty fast. It's negative 4x plus 6y equals 12. I just need to know what y would equal in this situation, so I will get y all by itself. 6y equals 4x plus 12, correct? Then divide both sides by 6, or all terms by 6, I should say. 4/6, what's 4/6 reduced to? 2/3. Come on, pen. There's still an x with it, and 12 divided by 6 is 2. Cool? What goes in the blank, though, is just what y equals. You only put the 2/3 x plus 2. There are an infinite number of solutions to this system, but only the ones that are on this line. So the ones that are on this line, x could be whatever you want it to be. You pick an x value, right? And then y would turn out to be 2/3, whatever that x value is, plus 2, right there. X, comma, y. Put an x there every time. Solve one of the equations for y. It goes in that blank. Next one. Let me put them in a new window. Place the capture in a new page. What do you want to cancel? He's all lined up for elimination. What do you want to cancel? X's or y's? X's. It doesn't matter. 4 and 6, least common multiple is a 12, correct? So turn one of them into a 12, turn one of them into a negative 12. Pause the video, get that done for me. When you multiply through, you should have got what I have here to the right. X's are gone, they add up to be nothing. Y's are gone, so you got 0 equals. Add those up, and you get negative 5. You know one solution is out because all the variables are gone. That is a false statement. 0 does not equal negative 5. So that means that there are no solutions to this. If I graph both of these lines, and there are no solutions, tell me about the two lines. They are parallel to each other. Right? These are parallel lines. The other lines were the same one both times. It was this line every time. You'd graph it twice. Right? They intersect everywhere. Groovy. Let's do this one. Right? So let's make our augmented matrix. 1, 1, negative 1, 0. What if there wasn't a variable there? Don't you put a 0 as a placeholder in its place? Like if there were no, we'll see that on the next problem, I guess. So what you got to do is go to second matrix, edit him. I need a 3 by 4 that I'm going to edit. And type that puppy in. 1, 1, negative 1, 0, 1, negative 2, negative 1, 6, 2, 2, 1, 3. You need to quit out of him then after you've got him typed in. Second, quit. Now, I'll go through the whole process since I wasn't recording before. You need to go to second matrix again, and you want to do math. Scroll up or down, it doesn't matter which direction you go, to option B, reduced row echelon form. Then you've got to select the matrix again. The matrix is B because it was sitting there waiting for you. Hit enter and it'll give you that. So now you write that down as 1, 0, 0, 0, 1, 0, 0, 0, 1. And the numbers were 3, negative 2, 1. Is that right? Is that what y'all got? So your ordered triple is 3, negative 2, 1. Cool. Again, we had a solution. Nice. Let's do that again on 13. If you need help typing this into matrix and you're out there in video land, you come see me and I will show you how to type this into matrix. Augmented matrix first. 3, negative 2, 5, 15, 1, negative 2, negative 2, negative 1, 2, 2. Uh-oh, there's no z's. Better put a 0 there, right? Because there were no z's in that bottom equation. There were x's, there were y's, there were z's. Then, second matrix, edit that puppy. Show you a shortcut now once you've edited it. That's an awesome thing to say. 3, negative 2, 5, 15, 1, negative 2, negative 2, negative 1, 2, 2, 0, 0. Got it all edited. Quit out of it. Now, isn't the previous operation that you are doing saying reduced row echelon form on B? If you want to go through all the procedure again, you could. Or if you hit second entry, like if you hit the second button and then where your equal sign is, that's entry. Doesn't it take you back to the previous entry that you put before, which is you'd like to do reduced row echelon form on matrix B? Hit it. It will do it for you, right? Because that was the previous thing that you just did. And then your matrix. Going one diagonally is good. That means you've got solutions. And those were 1, negative 1, 2. So that's my ordered triple. Cool. Why don't you do the next one, pause the video, get that done. Give me 2 matrices, an augmented and one in reduced row echelon form, and then we'll interpret it. Get me those matrices. Okay, so it's time to do the math on it. Second entry, boom. Oh no! Decimals, correct? You know how to turn your decimals into fraction? Math, enter, enter. Do the same thing. Hit math, enter, enter, and it will turn that into fractions for you. So now, let's write this puppy down. This is where you definitely want to write it down because, let me ask you this, did you get 1s going diagonally on this puppy? So you definitely should write this matrix down as a 1, not an 11. 1, 0, 31 eighths, 11 eighths, 0, 1, negative 11 eighths, 1 eighth, right? You can just hit your right arrow and it'll scroll it to the right. If you're not sure, if you hit the right arrow, it will take you over on that puppy. And then 0, 0, 0, 0. First thing you got to do is interpret that matrix. You look, since ones don't go diagonally, you have to read these two numbers. This says 0 equals 0. Is that true or false? That's true, which means you have infinite solutions to this one, okay? Because that's a true statement. But you need infinite solutions in the form of, so we've got to interpret the rest of this. So infinite solutions in the form. And now here's what you really have. This says x, y, z equals a constant, correct? What you always do is you set up your ordered triple, and the guy that is by himself is z. Z will always be z. You need to figure out what x is, and you need to figure out what y is. How come? Because doesn't this say 1x right there? How would you solve for x if you had this equation? X plus 31/8 z equals 11/8. I want to figure out what x equals. What would you do to get x all by himself? He's got to come over. X equals negative 31/8 z plus 11/8. Or if you had those switched around, it doesn't matter, right? But this guy has to come over here. So that's what x is. In my ordered triple, you've got negative 31/8 z plus 11/8. That's x. I need to solve for y. Isn't this right here, this 1, represent 1y? You with me? This is a z. Don't you need to add him over in that same equation? So y would equal, if I went off to the side, you'd have y minus 11/8 z equals 1/8. Don't you just have to add 11/8 z to both sides? Right? So y equals 11/8 z plus 1/8, and z is z. X, y, z is what they're in order. You have to solve for x, you have to solve for y, and z will always be z. Let me make up one more example of those because the next one's not an infinite solution. Let me make up one more example of just the matrix. Let's say you had this 1, 0, 2, and then 4, okay? And then you have 0, 1, negative 3, 5, 0, 0, 0, 0. Do you realize, first of all, why it's infinite solutions? Don't have ones going diagonally. 0 equals 0, infinite solutions. To solve for x, don't you just need to subtract him over here and put a z with him, correct? So you have negative 2z plus 4. Isn't that what x equals? You with me on that? Because this is the x place, this is the y place, this is the z place, and here's the constant, correct? What's y equal then? 3z plus 5, correct? And z equals z. Cool? This is what? Y'all cool with that? Last one. Let's go for it. Let's solve that bad boy. Go through the matrix problem in your calculator. Get me a reduced row echelon form matrix, and then we'll interpret it together. So pause the video, get that done. When going through the reduced row echelon form process, this is the matrix you should get. Let's interpret him. One's diagonally, no dice. Read these two. Infinite solutions or no solutions? What do you think? That's an infinite solution. 0 equals 0. If this was anything but a 0, you would have no solutions. That's the end of the problem, right? No solutions. This is infinite solutions. So we write infinite solutions in the form, and I need my ordered triple. Z is going to be z. I need to figure out what x is. Don't I need to add 5z to both sides? Doesn't this represent negative 5z right here? I need to add 5z to both sides. So 5z minus 1 Stop me if you don't get that, and I'll show you the work. You're cool with that? This says x minus 5z equals negative 1. That's what this line of information is. 1x, 0 y's, negative 5z's equals negative 1. Add 5z to both sides. X equals 5z minus 1. What does y equal? 4z minus 5. What does z equal? Z equals z. Section 7.5 in college algebra. Solvent systems again, just not linear systems every time. You can see the first guy, quadratic, because the biggest exponent is the 2. This guy is linear, and we have to solve them how they tell us to solve them. The cool thing is, at least we have a graphing calculator to check to see if our answer's right if you wanted to graph them both. But of course, to graph them both, wouldn't you have to get y all by itself on each one of these, you know? But let's use substitution to solve this system. Your choice of what to do. I feel the easiest one is we've got to get a variable all by itself on one side of the equal sign in one of these equations. It'd be pretty easy to get a variable all by itself in that equation, correct? You could solve for x if you wanted to. You could solve for y if you wanted to. I will look to the other equation to see what would probably be easier. In my opinion, it would be easier to get y all by itself, because then wouldn't we just have to substitute one thing in for y? If you solve for x, then you got to substitute all this stuff in for x, and then you got to square it, and then you got to do this, and you probably get a binomial, and you got to square a binomial. It's like, let's solve this bad boy for y right here. So let's do that. This would be negative y equals negative x minus 4. Watch that sign, correct? And then, of course, divide everything by negative 1. Y equals x plus 4. Are you cool with that? That means we can take this, x plus 4, and substitute it in for y into the top equation, because that's what y equals. So I would have x squared minus x minus 3, and where there's a y, you should put parentheses around him, because x plus 4 should go in for y is in parentheses, and that's equal to 0. Cool with what I've done so far. I will clean this up a little bit. This is x squared minus x minus 3x minus 12 equals 0. Correct? These are like terms. X squared minus 4x minus 12 equals 0. And now you have this quadratic equation that you need to solve. Quite honestly, if it doesn't tell you how to solve it, you can solve it any which way you want. If you want to use the quadratic formula, do it. I would check to see if this is factorable, though, and your guys' factoring is better than it has been in the past. Since the a value is 1, remember the number in front of x squared, can you find two numbers that multiply together to be negative 12 and add together to be a negative 4? Well, if you make a list of multiples of 12, first you should realize that one of the numbers has to be negative, correct, since they multiply together to be a negative. So it's either these two combinations, which that doesn't work, because that's either 11 or negative 11 when they add up to. Then you go with 2 and 6, but one of them has to be negative. And isn't this your winning combination right there, that a positive 2 and a negative 6 work out? So since this is easily factorable, it's x plus 2 times as a quantity, x minus 6 as a quantity, and it's still equal to 0. Questions on how I factored that? You don't have to do all that frowny face factoring, is what I've always called it, because the a value is 1. When the a value is something other than 1, then you got to go through all that work, which we'll do some other day. Now you use what's called the zero product property. You got a green guy times a red guy, because you always take a blind eye to what's in the parentheses. It's just a green thing times a red thing multiplied together to equal 0. Shouldn't it be true that one of those things would have to be 0 for that to be a true statement? Like if the green thing was 0, 0 times whatever the red thing is, shouldn't that turn out to be 0? Well, what value of x would make the green thing turn out to be 0 if x was how much? Negative 2. It could have been possible that the red thing could have been 0 also. What value of x would make the red thing 0? Either one of those two situations would be a true statement. What you could have done also is graph this blue thing, and that's where it crosses the x-axis, but unfortunately, they want you to do the algebra. So now we're trying to find the two ordered pairs, so we have to substitute back in, and we've got two different situations. Why don't we set up our two ordered pairs? First off, this is what it's telling us. I know the x values. In one of those ordered pairs where they intersect, x was -2, and in the other ordered pair, x was 6, right? So here's my two answers right here. Let's put -2 back in. Where would I put it back into? Probably the box. Wouldn't that be a pretty simple situation to see what y would be? This is so simple that you don't have to show me any work. You know, when you're substituting back in for y, I mean, this is as easy as it gets. -2 plus 4, how much? 2. And that was when x was -2, though, correct? So that's why it went for this y value. What about if x was 6? What would y turn out to be? And these are our two answers. This is what, if you graph this top guy and you graph this bottom guy, it would be a parabola and a line. That line would cross that parabola at those two particular points. Woo! Next, use substitution to solve for this. We know what y is equal to already in this one, so why don't we take this and substitute him in for y? Is there any coefficient in front of the y at all besides 1? So I really don't even need to worry about putting parentheses. I'm going to say that this is 2x, and then that entire box comes down. All of that stuff goes in for y, and that is equal to 4. Cool with my substituting. Since y was already by itself in one of those equations, I just put them in there. Now, these guys, it is quadratic because you got x squared and x to the first, but since these are like terms on the same side, what does 2x and a -2x add up to be? Nothing. So you got -x squared plus 8 equals 4. Right, these cancel each other out, right? They added up to be nothing, right? Subtract 8 to both sides. Because x squared is all by itself, or sorry, there's no x to the first, you only have x squared. Let's get x squared all by itself. Divide by -1, x squared equals 4. And now since it's only x squared, no x to the first, how do you get rid of the square? You square root. So you got to be very careful. What's the square root of 4? Plus or minus 2. There are two different answers to that. X could be 2, or x could be -2. So again, set yourself up two ordered pairs. In one of them, x is 2, and in the other one, x is a -2. And now I'll substitute back in. I would probably go into this guy right here, to be quite honest with you. It's much easier. If I put 2 in for x, I would get, I'll just do the work right below this or whatever, 4 plus y equals 4. And I put 2 in for x right here. Right? Subtract 4 from both sides, y equaled 0. Not -0, that just says 0. Now put -2 in. That would be -4 plus y equals 4, and y could equal 8. So these are my two answers. I solved that system. That parabola and that line intersect in two places. Cool with those? Yeah. How do they want you to solve this one? Graphically. Let's graph both of those. Before I even try to zoom 6 it or anything like that, you should think before you graph. This is a cubic, correct? Which looks like a snake. Something like this, correct? This is a parabola. Can you tell me if this parabola should open up or open down? You're looking at that. Should he open up or open down? Should open down. So I should see something to the sorts when I graph that. Let's zoom 6 and see what happens. There's your snake. There's your parabola that opened down. Difficult to see. First of all, can you see there's two places right there where they intersect? That's all we're doing, is looking to see where they intersect. The question is, do you think that this parabola intersects this snake way down here also? What do you think? Doesn't this, let me make a little sketch for you. Here's all you see. there's the snake, and there's the parabola. But doesn't this parabola go on forever? And doesn't this snake go on forever? Shouldn't they eventually cross down there somewhere also? So first, let's find the two easy ones while they're on our window. Second, calculate. We want to find an intersection. So the first curve, the second curve, you can just hit enter. Then you got to guess. You got to put your cursor close to somewhere where you feel that is. So see my cursor? It's in the neighborhood, I guess. 4, 0. All right, so there's 1, 4, 0. Now I'll do that again. Second, calculate, intersection. First curve, enter. Second curve, enter. Guess. I have to move my cursor closer to that other place of intersection. I'll bet it's at 6, 0. 6, 0. But now the fun part. We've got to find that third place. We definitely have to change our y minimum. Change it to a negative 1,000 is what I would recommend. Just because I've done this and it's way down there. So that y minimum, negative 1,000, I will go by hundreds on that scale also. And let's see if we can see it. We've already found those two up there. Who cares? There's that third one right there. So if you second calculate him, he was at, I'll let you find it for me, negative 6. Yeah, that's what I got. Negative 6, negative 720. And that's a trial and error thing. You know, the hard part is understanding that there should have been a third point in the first place. It's like, because you didn't see it, you have to understand your graph from the Zoom 6. It's like, oh yeah, dude, that dude goes down forever, and this guy, they're probably going to cross paths somewhere. Cool? Pretty simple.